Good morning and welcome to virtual class 16. Today is Wednesday, May 27th. So I have three quick items to bring to you today. First of all, if you have not already submitted your lab on the energy of food burning or food burning lab, please make sure to do that as soon as possible as it was due on Tuesday. Second, today our Hess's Law will be new content and it will be the last new content for this year. It's really hard for me to even imagine that. And then finally, a reminder that a week from today, on Wednesday, June 3rd, we will be completing our last exam, and that'll be on thermochemistry. So I'm going to send it out to Kevin, who's going to introduce us to Hess's Law and talk about what it means. Take it away, Kevin. Okay, I am at the big board here to talk about Hess's Law. So as you can see, Hess's Law states that the overall enthalpy change in a reaction is equal to the sum of the enthalpy changes for the individual steps in that process. So what this little diagram down here is trying to show us is this. If we have a reaction, A goes to B, there's a certain delta H value, just like we calculated last week, associated with that reaction. Now, what we didn't talk about last week is there might be multiple ways to get from point A to point B. So the most obvious one is obviously along this path. But sometimes reactions are dangerous, sometimes they're expensive, sometimes they're slow. So for more than a couple of reasons, you might be looking for an alternate pathway to get the same reaction to occur, but maybe faster or maybe cheaper. Well, it turns out that as long as your pathway adds up to give you the same overall reaction, you can use the delta H values associated with these alternate pathways to calculate the delta H value for this pathway. So what we're going to do is we're going to look at a series of problems where we have a target reaction. That's going to be the reaction that we're trying to get. But instead of just going from point A to point B, we're going to use a series of equations that will add up to give us that target equation. Turns out when we add up the delta H values for those other alternate reactions, we'll get the delta H value for our target equation. So I'm going to send it back to the desk so that we can take a look at an example of what this might look like. Take it away, Kevin. Thanks, Kevin. All right, we're going to switch gears and take a look at an example problem. This is actually going to be your first homework problem, so please make sure it goes on your homework assignment and that you submit it with the rest of the problems later today. I'm going to send it out to Kevin, who's at the board, to go over this problem. Take it away. Thanks, Kevin. All right, I'm here at the board to talk about the first problem on the homework assignment, which I have copied down behind me. A couple of things that I want to point out. As long as one substance does not have different states of matter, like in one equation it's a solid and in another equation it's a gas, as long as the states are uniform throughout all of the equations, you can leave that out. So if you notice on the target equation, I kept the states of matter in there, but when I wrote out the other three equations, I left them off, and that was just to eliminate some of the confusion as we go about reversing equations and multiplying them. Now, couple of other things that I want to point out to you. We're going to get to do two different things with our equations. So the first option that we have is to multiply our entire equation by a coefficient. So if I, let's say, and I'm just making this up, if I were to multiply this entire equation by 3, that would mean I would have 3 nitrogens, 3 oxygens, and 6 nitrogen monoxides. And then I would also multiply the delta H value by 3. The other thing that you can do to manipulate these equations is you can reverse, you can swap reactants and products. So let's say that we like this equation, but we needed water to be on the other side. You can actually do that. You can reverse the entire equation. And when you do that, you flip the sign for delta H. So if we were to say, okay, this reaction is actually going to have water on the left side and hydrogen and oxygen on the right side, then the delta H value for that equation would be reversed. So we're going to begin by looking at this equation. I'm going to pick something up here, find where it is down here, and then try and match it up. Try and match it up with the correct side and try and match it up with the correct coefficient. What I don't want to do is I don't want to choose something that appears in more than one spot, so something like nitrogen, or something that doesn't appear up here, like nitrogen. So oxygen I wouldn't pick either because oxygen appears in 2 different spots. So I know I need to get 5 oxygen. Do I get 2 from here and 3 from here, 5 from here and none of these? So don't pick something that appears in multiple spots. So I'm going to pick water. Okay, the first question I'm going to ask myself is it on the correct side? Notice I didn't say right side. Is it on the correct side? So here, water is a product. Here, water is a product. So that's good. That means it's on the correct side. Second question, does it have the correct coefficient? Well, it has a coefficient of 2 here, but it has a coefficient of 6 up here. So I'm going to take this one and I'm going to multiply everything in this equation by 3 so that I wind up with 6 waters. All right, so I'm not going to flip it, but I am going to multiply it by 3. So I'm just going to put that as a reminder over here. So I'm going to multiply this equation by 3. So I'm going to get 6H2 plus 3O2 goes to 6H2O. And when I multiply all of this by 3, I didn't flip it, so I'm going to keep the negative sign. When I multiply it all by 3, I'm going to get negative 1,450.8 kilojoules. All right, for my second option, now I'm going to pick something else in the equation up here and find it down here. So let's say I pick the ammonia. So ammonia only appears in one spot right here. So the first question you're going to ask yourself, is ammonia on the correct side? The answer to that is no. So we need ammonia to be a reactant. Right now, ammonia is on the product side. So we're going to have to reverse the equation. Does it have the correct coefficient? The answer to that is no. We're looking for a coefficient of 4, and right now it has a coefficient of 2. So not only are we going to have to multiply this by 2, so that part's there, we are also going to have to flip-flop this right here. So we're going to multiply it by 2 and reverse the equation. So I'm going to jump back here. So I'm going to start writing this out. And one of the things that I would suggest to you is that as much as possible, try and keep your arrows aligned with each other because that just makes it a little bit easier as you're going through it. So I'm going to take the NH3 that was on the right side, move it to the left side, the reactant side. Now I'm going to continue with these two. So I have 2 times N2, so that's 2N2 plus 6H2. And now for the delta H, because I reversed the reaction, the negative 91.8 becomes a positive. And because I multiplied it by 2, it's no longer 91.8, it's positive 183.6. So I needed to get ammonia on the left side. It was originally on the right side. So I had to reverse it. That's why the sign changed. I also needed to make it 4 ammonias instead of 2 ammonias. So I had to reverse it and multiply everything by 2. You don't just multiply the one thing that you need. You have to keep all of the coefficients in the same ratio. So if you need to multiply something by 2, you have to multiply everything by 2. Okay, so we've now used 2 of our 3 equations. Let's take a look at our last equation. So in our last equation, you'll notice we have NO, nitrogen monoxide. It doesn't appear anywhere else. So we know that we need to get 4 nitrogen monoxides, and they have to be on the right side, the product side. So the first question is, are they currently on the product side? The answer is yes. So we don't have to flip the reaction. The second question is, do we have to multiply it by a coefficient? The answer to that is yes. I have a coefficient of 4 here, but only a coefficient of 2 there. So I have to take this entire equation and multiply it by 2. So now, when I rewrite this equation, I'm going to rewrite it multiplied by 2. So I'm going to get 2N2 plus 2O2, trying to keep those arrows aligned, goes to 4NO. and my delta H is going to stay negative because I didn't reverse the reaction, but it's going to get multiplied by 2, so I have negative 361 kilojoules. Okay, so now what I would like to do is to check our work. So, sorry about all that noise. So what I'm going to do down here is I'm going to cross out anything that appears the same way on both sides, just like in an algebra problem. So if you notice on the left side, I have 6 H2s. Well, I also have 6 H2s over here on the right side. So I can get rid of those 6 H2s. The next thing you'll notice is that I have 2 N2s on the left and 2 N2s on the right. So I can get rid of those. And that's good because they don't appear in our target equation either. So it's great that they cancel each other out. The last thing is, if I have something that appears on the same side, those can get added together. So my 3 O2s and my 2 O2s will become 5 O2s. So now I'm going to simplify this. So I'm going to keep my 4 NH3. I'm going to add together my oxygen to get 5 O2. On the product side, I have 4 NOs. That's a good part there. And 6 waters. So if I, after manipulating all 3 of these equations, if I add up all 3 of them, I get my target equation. So this equation looks exactly like this one. So now I can take my 3 delta H values, these guys right here, add them together, and I get an answer of negative 1628.2 kilojoules. That allowed me to figure out the delta H for this reaction without ever running this reaction. I ran 3 separate reactions down here, figured out their delta H's, and used that to determine the reaction delta H for this one. Okay, so your homework tonight is to finish problems 2 and 3. Keep in mind, the first question that you want to ask yourself is this on the correct side of the equation? Second question is, does it have the correct coefficient? All right. Good luck to everyone. I will post the answers to this, and it'll look very similar to what we have here. I'll post the answers to this so you can check your work. All right, I'm going to send it back over to the desk for Kevin, who's going to take us out for today. All right, thanks again, Kevin. Okay, so I'm going to sign off for today. Your only homework assignment is to complete the other 2 problems that are on the Hess's Law worksheet. I will see everyone on a Zoom session either at 10 a.m. or 12 p.m. Hopefully you can make time for that. If not, I'll be back on Friday with the review for our test next week. Hope everyone is doing well and staying healthy, and I'll see everyone soon. Bye.